Here at OpenStack, one of the big topics is 5G and what it means. 5G's fundamental requirement is that your communication is over a much shorter timescale. They're talking about 1 millisecond to get across the network to the data center. Now, a millisecond is an abstract concept for a lot of people. It's 1,000th of a second, and the United States, thanks to the speed of light, is roughly 60 milliseconds wide when you're moving stuff across the network. So if I was playing ping pong on the internet and I was waiting for the messages to get across the country and back again, I could do it maybe 20 times a second, which puts it in perspective as to what the real life implications of latency are. Pretty much every application in America right now will run in 1 or maybe maximum 4 or 5 data centers in regional hubs. And making these things work together is a major technical challenge, which is one of the things that Volt's been working on for the last couple of years. But 5G changes that. A lot of the 5G vendors and people pushing the technology are saying things that they'll be using it for autonomous surgery, drone control, the self-driving car, and so on. They're saying, for example, this is a real claim, that the self-driving car will produce 4 terabytes of data a day. Now, to check this, I went out of the conference center and walked next door to the Tesla dealership, where after a 10-minute conversation with a nice man, they revealed that what their cars do is they have a map of what their sensors are supposed to experience as they drive down a given road. That gets downloaded to them. If the car starts seeing different things like roadworks or changes in the road layout, it sends messages back to headquarters, who may or may not respond in real time. This is so their cars are self-driving and their cars are connected, but it's not a conventional command and control relationship, which to a certain extent undermines the case for 5G. However, the real usage for 5G is probably going to be in augmented reality and virtual reality. With 1 millisecond response times, I can have a VR headset with a 4K resolution, and I can turn around, and the network is fast enough to send me what's to my left before it doesn't show up on my screen. That opens up a whole new area of excitement. So, for example, retail could change drastically. The bookstore, which has gone away thanks to Amazon, could come back in a VR world, where you could enter a VR bookstore where your choices are there, your favourite books are there. You would walk down the World War I section, would be a section of trenches you could walk down. The car section would be a big car showroom, and there'd be other people there who share your interests. So the whole social aspect of it would come back. That kind of engagement would justify the technology cost of 5G. Remote surgery, which is fantastically unlikely, and remote controlled cars are also both unlikely. But 5G isn't going away, and it's going to be big when it does hit us. It will need drastic changes in the way we use technology. The idea that you can have one application in one data center is not going to hold up. Your application will be out near the edge, and you will have to manage hundreds of edge deployments. You'll have to find physical space to physically put your computer in that location. You'll have to have the bandwidth, you'll have to have the high performance required to maintain 1 millisecond of latency. A lot of the more interesting talks from here have been from people who are talking about how you get the most out of your hardware in this environment. And it frequently involves going back to bare metal. So one of the ironies of OpenStack is that half the people are talking about how to abstract it further, and the other half are talking about how to de-virtualize virtualization. So how does Volt fit into this universe? We're one of the very few databases in the world that can handle very high performance transaction processing in the millisecond range, and has already built a successful active deployment for multiple data centers. If you need to work with things which have got finite quantities, where you can hand stuff out once, we're very good at that. We anticipate that as 5G rolls out, we'll end up with federated deployments with 10, 20, or even 30 copies of a database throughout the United States.